Okay, let's try this again. Here we go. So draw a spinner where the probability of an outcome of white is 3/8. So if you draw a spinner, and it's obviously by color, right? So I'm going to draw a spinner, cut it into 8 parts. So, and I'm going to shade a couple, so it doesn't matter what color I use. So let me just make this red, orange, make that orange, make that orange. Let me just change. I'm going to make this blue, make this blue. So I have a spinner where 3 are orange, 2 are blue, and the rest are white. So if I were to ask you, what's the probability of landing on white? If I were to spin this, well, there's a total of 8 different outcomes, right? And how many are white? 1, 2, 3. So this would be the spinner that matches this. So question 2 says, give an example an event with a probability of 1. So an event that has a probability of 1 is 100%, right? So remember, if you go to that chart that we did in class, right, 100%, this is 0%, then we can write it as a fraction, right? 1 over 1, which is just 1. So it's something that is for sure going to happen. And I don't know, I'll just use the very common one. The sun, although it doesn't look like it, the sun will rise tomorrow. It's guaranteed to happen. Right? That's 100% going to happen. It says here that, so question 2, Masao and Brian. So Masao and Brian are finding the probability of getting a 2 on a number cube. So a number cube has 6 sides, right? So a number cube has 6 sides, right? And let me just make this, that's 2. The other one, this is 1. This could be 1, 2, 3, 4, whatever. So there's only 1, 2, right? So Masao thinks that the probability of getting a 2 is 1 over 6. And Brian thinks that the probability of getting a 2 is 2 over 6. Well, they're both right in terms of the denominator where the 6 different outcomes, right? So this is correct. The 6 is correct. The 6 is correct. But there's only one of the faces that it's 2. And 1 out of 2 makes this guy correct. The spinner is used for a game, right? Each probability as a fraction. What's the probability of landing on a 5? Well, there's only one 5, so it's 1 out of, and there's 8 total. Even numbers are this one, this one, this one, and this one. So there's 1, 2, 3, 4, 4 out of 8. Greater than 5, so 6, 7, 8. This is greater than 5. This is greater than 5, and this is greater than 5, and 3 out of 8. Not 2, so I want anything but 2, so not 2. So this is okay, this is okay, this is okay, this is okay, that's okay, 8, that's okay, and that's okay. So the 2 is not okay, so I have 1, 2, 3, 4, 5, 6, 7. 7 out of 8 chances to land on 2. An integer are all the numbers here, right? 1, 2, 3, 4, 5, 6, 7, 8. All these numbers are integers. So it would be 8 out of 8. Less than 7. Less than 7 is 6, 5, 4, 3, 2, 1. So it's 1, 2, 3, 4, 5, 6. 6 out of 8, right? And you can always simplify that to, of course, 3 out of 4 if you like, but that's okay. Next question. So there's a card game that has 25 red, 25 green, 25 yellow, and 8 wild cards. So that's an 8 wild card. So there's another. So what's the probability that I'm going to take that the first card that it's dealt is a wild card? Well, remember, we always have to find the total. So 25 plus 25 plus 25. Oh, and I forgot 25 blue. There's 25 blue. 25 blue. So 25 plus 25 plus 25 plus 25 is 100 plus 8, 108. 108 cards, and I want the probability that the first one is a wild card. How many wild cards there is? There's only 8 wild cards. So the probability is 8 over 108. So you can simplify to 4, let's say over 54. You can simplify again to 2 over 27. This, or this would have been just fine. A beanbag is tossed on the square at the right. It lands at a random number in the square. Write each probability as a fraction, a decimal, and a percent. Uh-oh, you can't see the colors. I'm going to pause the video and I'm going to see if I can get a color out here. Pause. All right, so I took a picture. Let's see if it works. So I'll put it here on the side. So this is for question, whatever the question that is. And it's for question, all these questions continuing, right? So hopefully you can see. Sorry, quality's not that good. So the first question says, what's the probability of red? Well, let's first find out how many there are, right? There's 1, 2, 3, 4, 5. There's 25 in total. So all of these will have a 25. And I'm going to go ahead and write over 25, over 25, over 25, over 25, over 25. So what's the probability of getting a red? Well, there's 1, 2, 3, 4, 5, 6. 6 out of 25. What's the probability of getting a white or yellow? White. 1, 2. Oops, so let me erase some of these. So white or yellow. So white or yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 25. Of green, not green. So how many colors are not green? Well, everything is not green. So it's 25 out of 25. P of blue, and I think these are blue. 1, 2, 3, 4, 5. So it's 5 out of 25, or 1/5 if you decide to simplify. Blue or red? Well, blue, there's 5, right? 1, 2. So, let me just do it again. We're counting all the blues and all the reds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And brown. Is there brown here? No, there's no brown, so it's 0 out of 25. Okay, so next one. What's the probability of picking something? Month at random that starts with J. Well, how many months in a year? In 1 year, we have 12 months. We have January, February, March. So January is one of them. January, February, March, April, May, June. That's another month. That starts with J. July, August, September, October, November, December. So it's 3 out of 12 or 1/4. What's the probability that a day picked at random is Saturday? Well, how many days are in the week? There's 7 days in a week. Which one is how many Saturdays do we have? 1 Saturday, so it's 1 out of 7. A number cube is tossed. Are the events of rolling a number greater than 3 and a number less than 3 complementary events? So we briefly talked about this. So think about, so I'll give you an example. So the probability of Mr. Cho winning tomorrow at March Madness is 20%. 20% chance of winning, which means I have an 80% chance of losing. Now, if you add these two up, it equals to 100%. So complements will always add up to 100, right? So I'll give you another one. So the probability of rain tomorrow, apparently it's very high, 90% chance of rain, which means there is a 10% chance of no rain. And if you add these two, you get 100. So that's what complements means. So the probability, so a number cube is tossed. Are the events of rolling a number greater than 3 and a number less than 3 complementary events? Well, a number greater than 3 is 4, 5, 6. So there is a 3 out of 6 chance. Yeah. A number less than 3 would be 2 and 1, and that's 2 out of 6 chance. So if I add 3 over 6 plus 2 over 6, I actually get 5 over 6. Is 5 over 6 100%? No. I needed this to be 3 over 6 and 3 over 6. Okay. A coin is tossed twice and shows heads both times. So you throw a coin in the air and lands on heads and then lands on heads. What's the probability that the coin will show the tail on the next toss? Well, the first 2 times have no relevance, okay, to the third one. So if you get, what did you get? On the first try, you got heads. You threw the coin in the air again, you got heads. And on the third time, you want to get a tails. What's the chance? Well, it doesn't really matter. It's always going to be 50% or a half, right? Because these two play no effect on the third one. Okay. A reporter says that there is a 40% chance of rain. What's the probability of no rain? And that's what I was talking about briefly a few seconds ago. If no 40% of chance of rain, 40% chance of rain, which means that no rain will be 60%. Okay. Write a real life problem with a probability of 1 out of 6. Oh my god. If there were 6 students, okay, I'm gonna write Tom, Mary, Peter, Paul, Jerry, and Simon. If there are 6 people, the probability of Paul being selected to go to Paris on I'm making this too hard. So 6 people enter a drawing. The drawing is for a free ticket to Paris. So the chance of Paul winning is how many chances? Well, he has 1 chance out of 6. There's probably better examples than that, but I think we get. So that's the first video.